Hello, I am one. This is a video to just give you a little preview of background of why we're learning about geometric transformations. Most of what I'm going to show you, you're not actually going to learn in this class. Some of it you will, but I wanted to just get you thinking about that there is a connection to algebra and even into pre-calculus of what we're going to learn when we talk about how um, geometric shapes can be moved around in various ways on the coordinate plane. So what I have here is just a bunch of uh, different kinds of graphs that I've put into Desmos, and so I'm going to show you one type at a time. So the first one we have is a linear equation. So this is what we call our parent linear function, y equals x. You probably recognize it. And then what we know is that there are a bunch of things that we can do to this in terms of slope and y-intercept that will change the positioning of the line on the graph, but it's still a line. So that's kind of really the theme here is we're going to be changing how something's positioned, but not really changing the fact that a line is a line. So here's one example. When you go y equals x plus 3, that line is still a line, but it's shifted up. If you go y equals negative x, it changes the slope, it reverses it. That becomes actually a mirror image reflection of it. You can increase the slope. Still a line, just a different direction. Okay, so that's an example that you're more familiar with. Okay, then we have quadratics. Here's an example of a parabola. So this would be the simple parabola y equals x squared. What happens if we put a negative in front of that? Well, it's still a parabola, but it's flipped upside down. What happens if we multiply it by 3? It's still a parabola, but it's sort of squished steeper. What happens if we add 3? It moves up. What happens if we add 3, then square that, and then subtract 2? A couple things look like it happened, right? But it's definitely moved to the left and down. Okay, so that's using the example of a parabola. Another kind of function that you're going to learn about, probably not until pre-calculus, maybe that's math 3 for you, is here's a circle. That circle happens to have a radius of 3 and it's centered around the origin. I can move that circle. And again, this is all things that you are going to be developing your skills so that you could recognize just by looking at that function, like the red function over here, what's going to happen to the original circle just by looking at it. And these are things that we're going to start setting up your conceptual understanding of in the next few weeks. I can change the radius. There's a smaller circle. Okay, so that a circle, it's hard to tell if it's like flipped upside down or anything like that because it's still a circle. So it's hard to tell if it just moved or if something else happened. Okay, and then the last one I'm going to show you, and I don't know how much time I have, is here's an exponential function, and we will be learning about these later in the year. So this is what an exponential function looks like. I'll zoom out a little bit so you see it starts out slow and grows faster and faster. This is an example of a doubling function because of the base of 2. What happens if we multiply it by 2? It flips it upside down. What happens if we I'm sorry, that was if we added a negative, it flips it upside down. What happens if we add 3? Well, it shifts the whole thing up by 3. But what happens if we add 3 in the exponent instead of afterwards? Well, there it shifted everything to the left. So again, everything that you see in the parent function, the original function, it still is that same thing. It's still an exponential function or a circle or a parabola or a line, but we can manipulate it by moving it around, stretching it, flipping it, rotating it, all of these things. And you're going to learn throughout the course of your mathematical career how you can do that within the function itself. So there you go. Hope you enjoy.